Okay guys, good afternoon. YubiKey, hot or not, or in other words, one-time passwords. Now, I'll tell you a little bit about the things that I know about one-time password systems, why I find them cool, and what kind of itches they do scratch, and what kind of itches they don't. And why those things, this is a YubiKey, why they are pretty damn cool for certain purposes. Not for all. Okay, one-time passwords are really, really nice. I like to use them, say, if I go to a friend's place and I have to use his computer to log on to my boxes. Sorry, I don't type in my passwords into any kind of hardware that I don't control or own. I care too much for my stuff. Professional paranoid, right? And if you've seen the labs here, you know that some of those actually are really monkey cages with glass walls, and where actually the displays face the walkway and the glass. So you can show the surf to your heart's delight. I don't like that. So this is when a password which can be observed safely because it's a one-time only is really, really nice and cool. And one-time passwords have been around a long time. The oldest well-known implementation is SKey. I think developed by Leslie Lamport, as far as I remember, ages ago, has been around forever. Straightforward mechanism. Trouble is, at that point, you had to pre-generate those things, and you had to print them out, and you had to scratch them off. Okay, later on, people started playing around with PDAs. You got the algorithms for SKey and other systems. Other one-time password systems are well-known enough and easy enough to implement on a PDA on a smartphone, but still, the one big issue that you have with a one-time password is it's a one-time thing, you don't remember it, it's horrible, and you have to enter it. You've got to read it off whatever kind of device, you've got to enter it. And that's when you make mistakes, and that's why they are, well, to some people they are more pain than gain. Alrighty, so how can we fix this? Well, one of the solutions, of course, is having a smart card reader on your PC, which not that many have, and using some smart card to do the authentication on your behalf. If the smart card's in, life's good. If not, tough luck. Trouble is, smart card readers haven't really taken off that quickly. And that's precisely where YubiKey, the makers of these YubiKeys, comes into play, because they have, in my opinion, solved the user-friendliness problem, or the lack of user-friendliness that one-time passwords have suffered so far. Because a YubiKey presents itself as a USB keyboard. That's it, no user interface necessary beyond USB. Alrighty, the other big issue, of course, with one-time passwords is that not all algorithms were as open as SKey. I'm pretty sure everybody in here has heard of RSA having a lot of fun with SecureID, with their tokens, their crypto tokens, earlier this year when they realized that they've got to replace about 40 million of them, roughly, give or take, because the seed values were shot. Yes, one of those. Very, very convenient, unfortunately, very, very close, which is another issue that YubiKey fixes. Okay, SKey, classic implementation, makes the password sniffing a non-problem. Algorithms are public, easy, straightforward to use. You don't need any special devices. The only thing that you need is you need to have the stuff pre-generated, printed out on some small slip of paper, or you need some kind of PDA or smartphone. I've used this for a long time. It's inconvenient. That's primarily what happens. And it's event-based. So every single time you have a password, you've got to scratch it out and you've got to remember that it's no longer to be used. Right. How does it work behind the scenes? A simple, straightforward hash chain. So there's a secret seed value which is known to the manufacturer, which is burned into the chip. At some point, the clock is started. Every 60 seconds, we perform SHA-1 or MD5 or whatever other kind of hash on this thing and transform this forward. Can't go backwards, can always only go forward. Fine, they're all lovely, except the commercially available ones are closed. Closed as in inaccessible, not reprogrammable, not resettable. If the battery is gone, it's gone. You can trash it because you can't repair it or replace it. The vendor knows the initialization settings, and the vendors generally give you some kind of API to verify that a setting is correct for a particular derived value, but in general they do keep the initialization settings. That's what called out RSA. So while they could have forgotten that stuff if they had set up a decent environment where only the buyer knew the relevant material, they didn't. And that's precisely what leaked out. Okay, so the crypto hardware tokens are cool if you have non-computer savvy people who just want a bank key fob. Lovely. But just about all of us carry these electronic leashes around anyway, smartphone, PDA, whatever. All of them have the guts to do sufficient amount of computation. Now, well, your phones do a lot more than mine. I'm still on a PDA phone, a Palm phone, I should say. So this is all good enough to do crypto or to do one-time password algorithms on the go. And they've got one extra cool benefit, and that is they've got some form of interaction capability. You have a keyboard, you have a touchpad, whatever. You can actually add extra key material, extra passphrases or pin into the thing. So you can make this into a real full-blown two-factor authentication environment. You need to have the tool with its secret that is burned in or stored, and you need a little bit of information in your brain. That way, one without the other is useless for authentication purposes, which is very, very nice. And the other thing is that most of the common devices that we have nowadays do have at least intermittent internet access. So having a clock on the thing is also not a problem, or having a decently synchronized clock is usually a given, which means we can do time-based one-time passwords. So not just ones that you have to scratch out or use at a particular time, but ones that expire within 30, 60, 90 seconds, whatever. Okay. Now, this is not a new idea either. This has been done for at least since the Palm Pilot has appeared. So about 10 to 15 years by now. And by now, amongst the many incompatible implementations, 3 have more or less become de facto or real standards. There's mobile OTP, HOTP, and TOTP. Mobile OTP is the earlier version of that non-standard. This never became a standard, but most stuff that understands one-time passwords anyway does understand that algorithm. Take clock, take some kind of pin input value, take some kind of initial seed value, mash it up, run it through MD5, truncate it to about 6 to 8 characters, give it to the user to enter. Done, thank you very much. Trivial, straightforward, does the job. It's time dependent, which means sniffed passwords are useless. It's hash based, and it's a one-time password system that does indeed require a second factor, which is good. Okay, very nice, but just like any other one of those time-based systems, you can run into trouble when the tokens and the server clocks are very far out of sync. But it works, it does the job. There's a Java implementation which works even on my crappy phone, so it'll certainly work on yours too. And that was the state of the art until 2005, when something called HOTP came out, which is actually standardized and which is very, very well supported. Since 2005, they have it as a standards track RFC. The Oath people, yeah, they all love these cutesy acronyms. The Open Authentication Initiative, those guys developed this particular standard as a variation of the mobile OTP stuff. Works very nicely, hash chain, but one big difference, it's event-based. So you don't have a clock, you don't need a clock, but instead the value changes every single time you request a password or you compute the next one. So it's like S-key, where you scratched out the used up ones. Which means if I gain one of those passwords, I read it before it's used, I can use it as long as I want, or I can use it until it is being consumed. Great, you can make the devices cheaper. You might even do a passive device, one that is bus powered or RFID powered or whatever. But on the other hand, these passwords don't expire. So not absolutely lovely. Second one is TOTP, which has taken a little bit longer to get standardized. May this year, RFC 6238 makes this variation of the same idea, a hash chain with a time input and a passphrase pin, as a not too badly supported standard. The implementations that I've seen out there, PAM modules, Apache modules, and so on, just about all of them implement at least HTTP and time-based version And a good number of them do all three. Why? Because they're really, really, really similar. Which of course makes it very, very convenient to pick just the most, well, the nice module and just get going with it. Okay, so far is it good. But, well, what about all these systems? What about, what's still the one thing that sucks with a soft token? With my mobile phone giving me some kind of cryptic string for me to enter, which expires. So I've got 30 seconds to actually copy this over, or even less. User friendliness, interface, I need to copy. I need to read from here, copy over there, and I need to do this relatively quickly. So it would be really cool if we could solve this user interface problem without requiring a smart card reader. And the YubiKey, or companies called YubiKey, the YubiKey people decided to do this in the form of, well, in the form of a dinky microcontroller, and put it in this thing, about 4 millimeters thick, which basically presents itself as a full-blown USB keyboard to the operating system. And just about all common operating systems nowadays, don't know about Windows 7, but the real operating systems do support hot plugging of keyboards without any kind of trouble. It's just another keyboard which is dormant, so it doesn't send any input events, except when you use the one bit of user interface, the capacitive button. If you press on this button, it'll give you the next password. There we go, here's the next key sequence. 640 was the one that was to be given right now, and the next one, of course, will be different once I manage to give it right. And every single time we do this, we get the secret or the next one-time password and then a new line for convenience's sake. Okay, so user friendliness, tick, very, very convenient. What it is not is time-based. It's got no battery, no clock, no nothing on it. Of course, it's got some internal storage. It knows where it is in the sequence, but it doesn't expire in any fashion. Which means that, well, I get passwords that are given in sequence, yes, but they don't go away straight away. They can be reprogrammed. They support two different configurations. So basically, one slot you can use for classic one-time password, HOTP, or the YubiKey variation, or you can also use what they call a challenge response mode, where you have a little bit of software that actually sends the YubiKey a piece of input data. A YubiKey performs SHA-1, which is hashed message authentication code, so it proves that it has the secret, and then it sends you the response back. Right, without, of course, disclosing that secret, which will only live on that particular piece of hardware. Which means that with very, very limited amounts of extra help or extra application help, you can get, at the very least, standard event-based one-time passwords, YubiKey's one-time passwords. You can even program it for a static fixed string, which is a little bit silly, but hey, you can do it up to 64 characters. So it's certainly better than trying to remember 63 characters of random gibberish. And, well, the coolest thing of it all is, in my opinion, that you don't have to trust YubiKey, because they tell you precisely how to reprogram the thing from scratch. They start with a seed value programmed in one slot, which is known to YubiKey, but you can replace that straight away at any time. So you can, with the YubiKeys, we will never ever end up in the RSA scenario where RSA gets hacked and got an awful lot of mess rains down on every single user of those devices. Well, if you choose to run your own authentication environment, if you choose to reprogram your YubiKeys, that's it. YubiKey does not know anything, or does not know what you feed, what you put on the stick. And of course, they're write only, so you can't read out the material unless you have, unless you have an electron microscope and you're really good at reverse engineering. So, no trust required in the provider of the infrastructure. A very, very convenient default mode where it just does the USB keyboard thing, and advanced modes like the challenge response mode mean to me that, yeah, it's a cool toy. It may not really be the one and only solution for for authentication forever, but it's certainly a step in the right direction, especially when you combine it with something else like a smart token on your phone. Alrighty, that's it.